Hi everybody! Today we're talking about async, and that includes asynchronous programming, asynchrony, how it works a little bit, and an abstraction called promises that we use to deal with it. I know some of you are struggling with promises right now, and I want to say, when I did C1 a few years back, I was doing primarily add dataset, and I remember thinking at the end, oh my gosh, I don't have as many lines as my partner, did I not contribute much? But one thing that I did learn from being a TA in this course that I wish had been made clear to me at the start is that my partner didn't struggle with promises the way I did. He didn't have to learn them. Well, I mean, not at least to the same kind of depth that you add dataset folks are going through right now. So, yes, it is a lot to learn, and hopefully this lecture eases the pain a little bit. So let's get into it. First, why do we go through this all? What's the motivation? Here is a very simple program that involves a file system read, and as you may remember from CPSC 213, that's a pretty slow operation. The first thing we do is we import from the file system. Then we start reading a file, and as we know, this is a very slow operation, and this takes a little bit, and eventually it gets assigned to text. Next, we log the text, and then we log hello world. Easy peasy. But that logging of hello world, that was completely unrelated to the logging of the text. Well, what do they have to do with each other? The nitpicky of you in the audience may say that the file log is supposed to happen before the hello world log, but as the author of the spec that is not shown, I assure you that the two are unrelated tasks. Why is it that the hello world log is waiting for the file log, which is blocking? To fix this problem, we can write code such that it operates asynchronously. First, I define a function, file content handler. This is a procedure, or a to-do, if you will. Next, I initiate a file read. Some I/O controller in another part of your machine is loading data into memory, and while that's happening, we can move on. So next, I immediately log hello world, and then whenever the file read is complete and we have the opportunity, then and only then are we going to call file content handler. Those of you who remember 213 might be thinking of assignment 7, I think it was, and the interrupt handlers. That's a lot like what file content handler is. For this to work, I knew beforehand that the file system API wants a callback with an error message, an error parameter, and a text parameter. No matter what parameters I write, what parameter names I write on this function, the file system will always call this callback with an error or null in the 0th position, and the text as a string, if successful, in the first position. So file content handler gets called eventually. We don't know exactly when. We only know that it's after the log of hello world. This prints first, and that happens whenever. So this function here, often you'll see it inlined. It's a function without a name, and which you might call a lambda function. In the JavaScript world, the syntax is called a fat arrow function. The only problem with the inlined version is that if you're new to programming this style, you may read it and think that the log of the text is going to happen first. And that makes sense. You read it in this order, and you see first thing an import, then a file read, then console log text as the third line, and then here at the bottom, hello world. Okay, so you think it might go in that order. However, the log of the text is wrapped inside a function, a lambda function. This here is not a function application. This is just the function being defined and passed to the file read. Just like a method in a class or any function definition in a file, it doesn't get called until you put the 2 parentheses at the end. And this relates to a common problem that many students have with async code and debugging. They put a breakpoint here at the import statement, and then they step down here to the file read, and they press step again, and they expect it to go to the console log, but it jumps down to this log of hello world. And I'm often asked, why is it skipping my code? Well, it's not skipping it, it just hasn't executed yet. So again, first we initiate a read file, and we give it this lambda function as a to-do. Then we immediately move on to logging hello world, and at some point in the future, someone else, the file system API, will call the function that we gave to read file. Now, how does this all work? I'm sure you remember from either 213 or 221 the stack abstraction. As soon as a function is called, a frame gets pushed onto the stack, and when the function call ends, it gets popped off. In this very simple example, we start with an import, and then it gets finished. Then we read a file, and this one takes a while. A few million cycles go by, and then it's finished. We then log the file, then it's finished, then we log hello world, and then that's done too. So how do we do this asynchronously? I know there are alarm bells going off in your head about mutexes, deadlocks, and the well problem, but don't worry, it's JavaScript. It's TypeScript. That is to say, it's single-threaded, meaning you'll never have to worry about preemption, where in the middle of an instruction your process gets kicked out of the CPU and another takes its place and operates on shared data. JavaScript uses a control mechanism called the event loop. It starts off the same as before. We have main, and then an import, and then it finishes. Then we initiate a file read. This function here, this lambda function, the file content handler, is defined here, not called. Instead, it is immediately put onto the queue down here. While we're doing this, some I/O controller is writing into memory, but we're going to just move on. Next, we log hello world, and then it finishes. And now that the stack is empty and the file read is complete, the callback can get promoted to the stack. It's called, and then the log of the text is called, and that finishes, and the callback finishes, and now we're done. This bit can be confusing. In the slides, there's a link to an interactive demo of this process, so feel free to pause and come back after playing with that for a bit. Now, knowing what you know, let's say I have a function named setImmediate, and all it does is it takes a callback and puts it on the queue. What's the order that these two strings will print in? This is where I'd ask you to pause and think, but we both know you're not pausing, so the answer is world hello. Now, why is that? First, we call setImmediate, which puts the log hello on the queue. We immediately move on. We log world. Now that the stack is empty, because we're done with all of our computation, we promote the head of the queue to the stack. We've done it. We've figured out all of asynchrony. Until I give you a new problem. Imagine I had a file read, and after that finishes, I want to check the error. And the error is, if the error is null, I have another file read. Okay, so you can imagine in that callback, I would have a file read, and in that file read, another callback. It's like nesting dolls, a callback and a callback and a callback. And we quite bluntly call this callback hell. And to get out of this, we introduce an abstraction. It's called a promise. And the point of a promise is to help you deal with asynchrony. It's to make it work for you much more easily. First, we'll talk about how to create a promise. A promise is a class. Like the classes you've seen, it has a constructor, as you can see with this new keyword. The promises constructor takes a callback function. Here's another inlined fat arrow or lambda function. This callback function passed to the promises constructor should have two parameters. By convention, we call them resolve and reject. Of course, they can be named anything you want because they're just parameter names. And the promised object will call this callback with the same arguments in the 0th and 1st position, regardless of the parameter names. So, what are the arguments? Well, the 0th argument will always be a happy path, and the first argument will always be a less than happy path. And when I say path, yes, I mean another level of callbacks. Resolve and reject are both functions, but they're parameters. So we don't know which function they will be exactly at the time of writing this callback function that we're passing to the constructor. What we do know is that when we make this promise, this whole callback is going to go on the queue. At some point in the future, it will start, we will do some work, and if things go well, we'll call the resolve function. And if things go poorly, we'll call the reject function. Still confused? Okay, that's okay. We're going to go through the next slide before you rewind. How do we use a promise? Pinky is the function from the previous slide. It returns a promise. A promise, again, is an object. It has 3 methods you could care about, but only 2 for this course. The 2 methods are then and catch. Then is a method of the promise that takes a callback function for the happy path. This here, this inlined arrow function, is the function we're going to pass to then. Catch is also a method of the promise that takes a callback function for the less than happy path. This function is the function that gets assigned to the reject parameter. So to see that visually, this function goes here, and this function goes here. Okay, so this is a pretty tough part of the day. So why don't you rewind and watch the previous slide, knowing what you know now. Both slides inform each other a lot. Are you here after your second viewing? I hope so, because this next slide is a doozy. Gosh, look at all that text. Okay, so with all that new information on the last slide, you might have not thought to ask, how is it that the catch is attached directly beneath the dot then? Well, that's simple. The return type of the method then is a promise. That means not only can you directly chain onto it a catch, but you can also chain onto it another then, because that is a method of a promise. And the return type of the promise returned by the then method is a promise that resolves with whatever the return type is of the callback that is passed to the then. And so you see here, make promise returns a promise that resolves with type number. That means when it calls its resolve function, which we pass to using this then here, it's going to call with a number. So we see the number here in this parameter position because a number is going to be used as the argument, which again, we see from here. And now the entire promise that gets returned by this then is going to be a promise that resolves with a string. And we know this because when we return string here, it's like calling resolve with a string. And what can we do with that promise that resolves with a string? Well, we can attach another then to it. You'll see that the parameter result is a string. This parameter here will always match the same type of the return type above it. You've probably also noticed that there's only a single catch at the very bottom. One of the nice things about a catch is that if there's a rejection anywhere in the chain above, it will go down to the first catch it finds. So you could have a chain of 100 thens and a single catch at the end would sort it out for you. My question to you now is, what is the return type of our promise? This thing being assigned up here. Some of you need another rewind. If you don't, hopefully you came up with promise Boolean. I would also accept promise true, but you did it. You made it through the hardest part of this entire tutorial. If this was in person, I would be very proud of you. But I do have one last promisey thing I wanted to share with you that I didn't know exactly where to put. Sometimes you have a bunch of promises. I promise to get data from the Google Maps API. I promise to get data from the Bing Maps API and another from the Apple Maps API. And I want all of them to resolve so I can take the average and alert the user. And I could do this in a couple ways. I could start by getting the Google data, and whenever that finishes, I get back the Bing data, and then I wait for that to finish too, and then I get the Apple data. Or I could initiate all 3 at the same time and have my average code run only when all 3 resources get back to me over the internet. To do this, I use promise.all. All is a static method of the promise class. All takes a list of promises and it returns, you guessed it, a promise. Just one though. and that single promise resolves with a list of all the resolutions of the input promises with their order maintained. This is only on the condition, of course, that every promise actually resolved. Okay, let's look at an example. Let's say I have a string promise and a number promise. I make a call to promise.all using an array of the two promises, and I get tuple promise. Tuple promise will resolve with a string and a number. The ith result comes from the ith promise. It's a way of doing a bunch of things together, a kind of synchronizing of asynchronous events. Whew. Anyway, you made it. That's all the things. Notice there are fewer of them? Those of you not convinced that this shouldn't be as difficult as 213, remember that you've spent weeks with 213's asynchrony, much less time with these promises. You'll get there. Especially if you do the exercises. You should find them linked on the course website and on Piazza and in the description of this video. And, well, I guess let's move on to those. You do them first, and then you come back and watch me do them, okay? Okay, so now I'm here in the project. The first thing you should do is open up your terminal and run yarn install. I've already done this though. So I guess let's open up the exercises and look around. So the first exercise, print a welcome. So we'll be using this service here, async service, which at some point in the future will print a message for us, and then it will call this callback after the original message has been printed. Well, first, why don't we just try calling this 3 times? I don't really need this here. Okay, so the second thing it needs to print is class. The last thing it needs to print, how are you? Okay. Maybe I've done it. Let's look at the exercises, tests. The first test will print a welcome, print a welcome, print a welcome. And it expects that we should get hello class, how are you 3 times. Let's try running it. Okay, so let's see what order we got. We wanted hello class, how are you 3 times. We got how are you, hello class, how are you. That's good. Class, how are you, hello. Okay, so it looks like things are not coming out in the exact order we want with all this asynchrony. Remember, when we have asynchronous code, it will happen eventually. We don't know exactly when. So let's try and synchronize it. Well, we know that this callback will happen after hello. So let's expand this. We also know that this temp here is going to be error or null. So let's give it a better name. Error. And it does say if there's an error, we should console error oopsie. So if there's an error, we will console.error oopsie. Okay, looking okay so far, and only after that has succeeded. Well, let's actually copy this. Only after that's succeeded. Oh gosh, this is already terrible. This is a second error. And hello class. Okay, and only after that has succeeded do we want the how are you. This is error 3. This is just for error checking. The how are you is all that's remaining. Okay, that looks terrible. Well, let's see if it worked. Excellent, test passed. Okay, so to the next exercise. Oh. Okay, promise to print. So we have async service, print and then, that needs to get turned into a promise that only resolves after it has successfully printed. Okay. And it also says that there's a hint, start by returning a new promise. So let's start with new promise. And we know that a promise takes a function, and the function's parameters should be resolve and reject. Okay? And we know that async service print and then needs to get called. So this is the actual method that is doing the printing. And it's going to be printing our message. So let's start with that. Message. Okay, so what's our error? We are missing an argument. Let's go see. The argument is supposed to be a callback. So we can start by saying we need an argument. It is an error, and we will return void for you. We know that this callback will only get called after the message is printed. So we can resolve like that. Now, do we resolve with something? Well, we know that this is a promise of type void, so we should be resolving with nothing. If this was a promise of type string, then we would, everything turns red until I put a string here. Hello, and also say that this is string. But that's not the case. Oh. Okay. Are we seeing a problem? This is not getting called at all. We need to reject. Let's say if there was an error, instead we reject with the error. And only in the other case do we resolve. Let's move that over here. Okay, looking pretty good. Let's run our tests. Should make a promise to print. Oh, test passed. Perfect. Okay, so next exercise. Using promise to print, make the given strings print in order. As an aside, can you imagine writing that using this? How unfun would that be? How much horizontal screen real estate would it use? Too much. But we already have something written here, so let's just see what it does. Well, we have to return a promise that is void. Well, I can do that using promise.resolve really quickly. What promise.resolve does is it makes a brand new promise that immediately resolves. It's great for stubs. I just want to know what's getting printed right now. This is probably not going to be in my final solution. Let's go back to here. And let's run this test. Should print a response. Okay, so turns out that all of our responses are actually printing after we're checking them. So this is what we were expecting. We didn't actually print anything in any order at all. Not great, not a great start. Well, we have a promise. Maybe we could start by returning this. Let's return this promise. Okay, well now we have a new problem. This is never going to get executed. But we know that after we print something, only then will the code in this chunk be executed. Let's see what the error message is. Trailing white space is not allowed. I think we can handle that one. So maybe after that, after this prints, then we'll do this print. Then we'll do the next one. Okay, so looking a little bit better. Let's try running that test again. Should print a response. Let's run it. Okay, still failing. What? We only printed hello. Okay, let's look again. What are we forgetting? Well, you might not be able to see, but there's a little green squiggly right beneath promise to print. Let's see what it's doing. Promise returned from promise to print is ignored. Okay. What does that mean? Well, what it means is I'm not doing anything with this promise. I'm creating the promise, and at some point in the future, Elise is going to get printed. At some point in the future. And the same with this. All of them is going to be at some point in the future. But we didn't synchronize them. This then is not being called after this promise, because it's just being made and thrown into the wind. We don't know when things are going to happen at all. In order to synchronize it, we return this promise. And now this promise becomes part of this overall promise. So only after this promise resolves, only then do we call this next method here. Okay, so all the return statements are in place. Let's try it again. Oh, beautiful. Everything passed. Green check marks. Final exercise. Get midterm subjects. It returns a promise that resolves with a single array containing all the midterm subjects. I think there's a pretty big hint there. If there's an error, it should console error oopsie and resolve with an empty array. Okay, we'll deal with that part last. But we have these 4 midterms, each with their own set of subjects. Okay, let's see. Well, we have future midterm 1 subjects, so that's a promise. We could say this, and when it resolves, what is it going to resolve with? It resolves with a string array. Those will be the midterm 1 subjects. So here, this will be midterm 1 subjects. Okay, good first start. We have the first thing we need. Now, let's say maybe future midterm 2 subjects dot then. Okay, so actually we probably don't want to use then here, because this future midterm 2 could have already resolved by now. Like, we could have missed the boat on attaching this then. So maybe we don't want this here. Okay, well maybe what we want to do is call this in here. Let's say maybe we don't want this, and we'll say future midterm 2 subjects, and then, okay, getting somewhere. Yes, this is midterm 2 subjects, and yes, okay, and then we'll do the same thing with 3, the same thing with 4. And then we need to be returning a okay, so we need to be returning a promise. So return new promise. I'm feeling okay about this. Resolve and reject, and let's take this and move it down here and fix our indentation. And let's pretend for a second that we did the same thing for midterm 1, midterm 2, midterm 3, midterm 4, and we will resolve with midterm 1 subjects dot concat midterm 2 subjects. Okay, so this would work. In fact, I'm going to run the test even though it's not finished. I'm going to see what we get. And set a breakpoint right here. I'm going to debug this. Okay, testing process history requirements. I mean, it doesn't have everything, but we didn't finish writing it yet. So far, it's actually looking really good. But I now pose this question to you. What was the point of doing it like this? Like, why did we wait for midterm 1 subjects to finish before we started getting midterm 2 subjects? this sounds a little bit like our original problem with synchrony in the first place. We're just blocking for no good reason. Okay? What we really want to do is initiate all of these at the same time, and then when all of them are finished, only then do we resolve. And we've seen something to do this before. Okay, so let's delete this. We went down the wrong path. Let's say promise.all. Promise.all takes an array, right? So future midterm subjects, all future midterm subjects. Okay, well let's create that. And it's equal to, okay, and semicolon. Here we go. Future midterm subjects. So then we will have midterm subjects. So it says it is a string array. Here it's getting a little dicey. Let's actually set a breakpoint in here and see what's going on. Firstly, we just need something we can set a breakpoint on. And let's set the breakpoint here. Let's not forget to return our promise. And let's just take a look. Okay, so at this point in time, midterm subjects. Oh, there we go. Testing, process history requirements, refactoring, REST principles. Okay, so we have a bunch of arrays, and we want to join them all. Luckily, I can do a little bit of JavaScript magic. Luckily, I can use some JavaScript magic. The first thing I want to do is return an array, and that should make the red go away because now I'm obeying the prototype, and I'm using a string array. Well, any empty array is a string array, and I'm not returning void. Now this array, I want to concat onto it another array. The thing is, concat can take an arbitrary number of arguments, so I could say something like midterm subjects 0 and then midterm subjects 1, and it would take and it would return these two arrays both concated onto this empty array. Or another thing I can do is use the spread operator. What this does is it takes the 0th element of the array and puts it into the 0th argument position, and the ith element of the array into the ith argument position. Okay, we're almost done. We just need to add one last little thing to obey what the spec said. It said if there's an error of any kind, it should console.error oopsie and resolve with an empty array. And remember, if any of these promises reject, then the single promise from the promise.all will reject. So I can put here error, and if any of those promises reject, it'll go to here. And I should console.error oopsie, and then I should resolve with an empty array. I'm feeling pretty confident. Let's try running all of the tests. Compiling, running, and they all passed. Look at that, we're done. We did all the exercises. Good work. If you made it this far, you've done it. Whether you had to look at what I did or if you're able to do it yourself, either way, you have everything you need, all the tools now to do checkpoint 1 and be successful. I promise. Yeah, that's it. Have a good day.